locations that you want to move gas from to. So there may be political issues that would stop you doing that, or geographical issues. But if you were able to do that, there's a crossover when LNG becomes more effective than building a pipeline. And so you can see that for offshore pipeline, these are ranges, obviously. You have onshore, low pressure pipelines, high pressure pipelines, and LNG is quite flat. Once you've built the LNG and built the ships, you can send them a long distance at relatively low incremental cost. So depending which situation you're in, you can see the sort of number of miles that you have to be sending the LNG for it to be cheaper to use an LNG solution. The other political issue you have with pipelines is you can't divert them. And once you build a pipeline, you build a pipeline. But I think the Qataris said that they wouldn't do any more pipelines. They have a pipeline currently down to Abu Dhabi, I think it is. But they've made the statement that you can't divert the pipeline. All you can do is switch it off. So they continue to build LNG, not new pipeline capacity. This is a broad look at the international LNG trade. As the industry's developed, the distances have become longer. Initially the distances were sort of within Africa to Northern Europe or within Asia. Now the trade is very much global, and what comes with that is issues like the Panama Canal. And your access to the Panama Canal, access to Suez, and so on become issues. But it's no different to other global trades, like the oil trade. You do have less flexibility in LNG because the product is boiling off while you're transporting it, and you lose around about 0.1 to 0.15% of the cargo every day. But it sort of depends what the weather's like and things like that, but you're roughly losing about that much. The focus of the LNG shipping industry has sort of been twofold over the last 30 years. The first one is to make the installation more efficient, and they've been successful in doing that. The second one, well, it's threefold actually. The second one is make the ships bigger for economies of scale. And the third one is to improve the propulsion technology, so make them use less fuel. So it's a fairly typical optimization type activity that's been going on. A good example of a crisis is the issue with the Houthis in the Red Sea. And what does that really mean for the industry? And I think what it means is that there'll be some incremental costs because of that, but it's not fundamentally going to change or stop the LNG trade. The people who would probably hurt most would be the Egyptians in the Suez Canal, because that's going to be used less than if it was open as normal. There are always different routes around to make sure that product arrives. Just you need more capacity, which will mean that the cost of shipping will go up in the sort of short term, and then that will generally come back down again and stabilize. I did mention the Panama Canal. This is quite a significant bottleneck, especially given that most of the new production is going to be from the US, and this part of the US, not this part of the US. So if it goes to Europe, fine. If it goes to Asia, some of it is actually going in this direction, which is further physically, but access to the Panama Canal can be problematic. And if you're having to wait to get access to transit, that's maybe less of an issue if you have a liquid that isn't boiling off. But if your product is actually boiling and disappearing as you sit there, that's more of a problem. Some of the newer vessels actually have reliquefaction technology, so they can reliquefy as they go. But of course, that takes power as well, so you're using more of the product. But so the issue in the Red Sea will increase some cost to some extent, but not fundamentally change things. This is the LNG shipping stats for 2023. There are 700 vessels active. 43 built in the last year. So it's a relatively small fleet actually, compared to other commodities. It's not that large. 47 of these are FSRUs, but it's continuing to grow. And there are a lot of tankers on order. One of the issues is there aren't that many places to build LNG tankers these days, and they tend to compete for yard space with container vessels, which also went through a real spike in demand post-COVID. So if we look at the LNG tanker types, there are actually even more types than this, but the two large types, I'll start on the right, the old Moss ones. These were the original ones, and they have the very distinctive semicircle domes on them. And those they're spherical, obviously. They go down into the hull, and you fill them all the way up, which means you have quite a small surface area on the top, which helps with things like sloshing. And they were originally built in Japan, but they do have some disadvantages. They tend to be slower, heavier, and less efficient in terms of use of the space. There are a lot of gaps between the spheres. But you often see people want to talk about an LNG tanker. That's the one you look at. But they're not really built anymore. Membrane ones are more square, and if you remember that picture of the inside of the tank I showed earlier, it's sort of what they look like. So they're lighter. They're a bit less robust than the Moss ones, and they're mainly built in Korea and China now. Korea is the biggest constructor, but almost everything built now is a membrane style design of some sort. So that's looking at the inside of the tankers. As I said, the Moss ones are these spheres, whereas the membranes are square and therefore more efficient. So the shipping fleet has been getting steadily bigger as people have been chasing economies of scale. So this is the existing shipping fleet statistics between 2021 and 2022. So you see that the only ones that got bigger, apart from the small ones, which that's the LNG bunkering market. So this is where you have smaller vessels that will go alongside and bunker, put LNG bunkers into larger vessels. So they are being built. The other ones that are being built are these larger ones, 170,000 cubic meters or larger. I'll talk a bit about these ones. There's some very, very big vessels out there that were built 10 to 15 years ago, and now maybe coming back. But right now, it's just over the years, the vessels have just got bigger and bigger. It's a relatively young fleet. There are a couple of reasons for that. The industry has expanded quite quickly, so it's needed more capacity. Therefore, the vessels are quite getting more new vessels being built. And the other one is that the technology tends to get outdated quite quickly. So things like the propulsion or the insulation, which doesn't really happen with other. Maybe it does on propulsion, but less so, and certainly not on insulation with other products. So it makes sense for people to be upgrading their vessels to make them more efficient all the time in a way that doesn't quite with other commodities. This is the increase in bunkering units that you can see just here with dark blue over the last 0 to 5 years. So the LNG bunkering is an interesting opportunity to decarbonize or reduce the emissions. Well, it's not so much decarbonize, reduce the emissions from vessels that have previously used much heavier fuels, sometimes with higher sulfur contents. So if you move to LNG, you reduce that sulfur content. And but what you don't really do, you improve your greenhouse gas emissions as well, but maybe not as much as you might expect. So one of the questions the industry has is, do we leapfrog over LNG and go to something like ammonia or some other fuel that has a much bigger impact on greenhouse gas emissions? This is sort of a word salad down here of different types of propulsion technology, which I'm not going to go in, but they just generally get more efficient as you go. Most can use multiple fuels, so they can burn things like diesel, they can burn the LNG cargo itself, and the reason for that is it then gives you the ability to use whatever's cheapest at any particular time. Boil off is around about 0.1% of the cargo per day, so obviously 1% every 10 days. What's it cost to build one of these things? It's varied over time. It's a number of factors. One of which is just the cost of steel, and you can see around about 200 million is the cost of an LNG vessel. Post-COVID, everything went through the roof, but then that happened to almost everything anyway. So you can see the cost now is up in the 250 million range. There is, it takes some time to reduce or increase the number of yards, construction yards, that are able to build these sorts of vessels. Building the insulation is very time consuming. Needs a lot of accuracy and high skilled workforce. So increasing capacity is not as easy as it is with some other types of vessel. What does it cost to charter one of these? So this goes back quite some time, but these are LNG charter rates. So it goes back to 2006 all the way up to 2018 in this case. So you can see the variability is very, very significant. So this is zero, and this is $160,000 a day. And so it's very much supply demand dependent. And what you'll find is that when this sort of grey columns here are the number of ships available for charter. So you can see when that goes right down, the charter rates go right up. So what you will find generally is that when the market tightens, the availability of shipping just disappears, or goes very, very constrained really quickly, because it's not that big a fleet. So having some control of your shipping fleet is very important from an energy security point of view, as well as a straight up logistical point of view. Because when the market's sort of slack, as you see over here, lots of availability, low price, it can feel like you don't really need to charter shipping. You can just take a chance and pick it up on the spot market. But as soon as you really need it, you'll find it's not available. This is just going out past the end of that previous chart, and you can see some pretty significant winter peaks going on here. The charter rates are going up as the winter comes through. In 2023, where is that? The IGU, which is the International Gas Union, has reported on average rates for steam turbines. And I should maybe talk about the original LNG tankers used steam turbines, which is quite old. your old technology, and they're not being built anymore. They're really being phased out at this point. And these newer ones have significantly higher day rates. So an old steam turbine vessel might be 54 on average. The newer ones, I think TFD is tri-fuel diesel electric, would be closer to 100,000, 120,000. But controlling the shipping fleet, because it is so unusual and it's so difficult to get short-term tonnage when you really need it, is one of the real value adds you get from a portfolio player. So that's like the Shells and the BPs and so on. This is the increase in LNG bunkering. The IMO, the International Maritime Organization, they reduced the limit on sulfur in fuel from 3.5 to half. I think that's 2020. It was IMO 2020, and that really drove the demand for LNG as bunker fuel. And so these are small vessels that will carry LNG around a port area or an anchorage, and refuel vessels. But to retrofit a commercial vessel with LNG, or LNG is quite expensive. You think you've got to find somewhere to put the LNG tank in the existing architecture of the ship. That can be quite expensive. So the trade-off that shipping owners will generally have is, do they put flue gas, what's called flue gas scrubbers, in and take keep using the cheap fuel and just scrub the sulfur out. And so that's an economic trade-off that they have to make. And then the final dilemma is, do we just not go to LNG and leapfrog onto ammonia, which of course burns without releasing CO2. You have to make sure it doesn't release other problematic emissions. But the real issue there is that the supply chain for ammonia doesn't exist yet in the way that you really need it to. So there are a lot of dilemmas for ship owners and uncertainty about how the shipping technology especially will develop. So that's it on.
All right, so we are done with the LNG shipping. Do you have any questions on this?
Hi.
Yes, from an investor's point of view, what are some of the considerations in deciding between putting up an onshore LNG terminal with a regasification unit located onshore, as against establishing an FSRU with a floating regasification unit? Like, what are some of the advantages or disadvantages from an investor's point of view?
So the advantages of a conventional onshore one are it can have more storage. It is more resilient to bad weather. It's expandable in a simpler fashion. They're often co-located with power generation assets. And you don't have to go away for an inspection every 5 years or whatever certification is required. The negatives are they're more expensive. They take longer to build, and they may have more permitting issues, or may not, but they may do. The advantages of the floating are they're quicker, generally cheaper from a capital perspective, but the operating costs may be higher. And that's the main things really. They're just quicker and cheaper for the FSRU. So, and from a long-term perspective, you're better off with a land-based one, if you're confident that your demand is going to keep going up, eventually you'll go to that. The FSRU is just more of a stopgap. Not always, but very often they're more of a stopgap.